If you end watching this video at one point, then please tell me what the reason was so that I can improve. Otherwise, hi and welcome. I'm trying to learn physics. Today, how light behaves. And after we've done that, we're gonna do body center training. And if you participate in the body center training, then it's at your own risk. Now, we're having this part here on this big double page about the basic properties of light. And we already read that in the previous part. Now we're gonna go over it, and we want to prepare a presentation with the title Different Interaction of Light with Different Surfaces, or the different interactions of light with different surfaces. And now we want to read the text and prepare then this presentation out of memory, out of it. The basic properties of light. The way the eye perceives objects depends on the way light interacts with the material of which they are made. So we're saying here, the way a human eye sees something, whether blue or white, with a human eye, depends on how the light interacts with this stuff. And that is what our presentation is about. Different interactions of the light with different materials or different surfaces. Light falling on an object can be reflected, scattered, absorbed or refracted, or all four may occur. An object's color is determined by the part of the spectrum that it reflects and does not absorb. So they basically said there are different types. There are things which reflect the light, like a mirror. There are things which absorb the light, like something like that. Like rough surfaces, there's the light not reflecting, so flat surfaces are reflecting, rough surfaces not. And when the color is some materials absorb many colors, and the color it has is the color which was not absorbed. So this book basically absorbs basically the light has the rainbow colors, absorbs 4 of the 5 colors, and just the dark one comes back or something. And this is the other way around, all come back. I don't really get it. Reflection. A flat surface reflects all the light falling on it at the same angle from the perpendicular at which the light strikes it. The eye sees a white surface. Now, I don't know what perpendicular means, but we're having a graph, I know what is happening. Okay, reflection can happen with one surface or one material. The light comes up in the same angle as it has struck it, and it appears white. Okay, reflection is possible, it appears white and it comes off in the same angle. Scattering is possible. A rough surface scatters light because each part of the surface reflects the light at a different angle. The object appears dull or matte to the eye. Okay, scattering is possible. It's a rough and wobbly rough surface, and every part of the surface reflects the light now into a different angle. And that makes it look matte to the dull or matte. Matte seems to be an English word. Matte or dull to the eye. Okay, absorption is possible. Some surfaces absorb more of the light falling on them than others. If light of all colors is absorbed, the eye sees black. It is possible that some material absorbs the light, and basically what I just said, I'm going to tell this again. The light has different colors. If there's a rainbow, then inside of the raindrops you can see then the different colors. And now you see the red, the yellow, the blue, or whatever. And basically some materials are taking now some of these colors out. So basically the red one, or the green one, and if all are taken out, all are taken out, then it is black. Some surfaces absorb more of the light falling on them than others. If light of all colors is absorbed, the eye sees black. Refraction is possible. The path of a light ray is bent towards the perpendicular as it passes from a medium such as air to a denser medium such as glass. It is bent from the perpendicular as it re-enters the less dense medium. Now understand something. It is bent towards the perpendicular as it passes from a medium, from air to a denser medium, and bends in a way. So we're saying, if there is light coming through a glass window, then the light coming in that angle, and as soon as it enters the tougher material to go through, it's gonna bend towards it, go through it, and then after it goes out, it will bend again back. I have no idea why, but that sounds very interesting. Okay, refraction. Is that the definition of refraction? It comes through a softer medium like air onto a harder medium like glass, and when it comes there, now it bends towards it if it comes in an angle. And when it passes out, it bends again from it. And that is now refracted. And we're having dispersion of white light. White light then passed through a glass prism. I think we're talking about normal light. Through a glass prism. It splits into the colors of the spectrum. This is because each color has its own wavelength, which determines the angle at which the light is refracted. Red is refracted least, violet most. We had here light has a wavelength of red has a wavelength. Red has a wavelength of 10 millionth of a meter, and blue has 0.3 for 10 millionth of a meter. 100,000 of a centimeter, as I said, is it? Seven 100,000, so 7 of 100,000 parts. 7 100,000 still 100,000th millions. 7 100,000ths of a centimeter. Has red light, and blue light has 0.3 of 100,000th of a centimeter in wavelength. And now because we're having all different one, green and yellow, whatever in the middle, they are going through the prism and then dispersing, coming at different parts out, split it up in where they are ordered, basically, or sorted, and now they're visible as different colors. Okay, and are we able to save it? We're going to save it light. Different objects have different things. It can be that some materials are reflecting. Reflecting, it comes in off in the same angle, it appears white. We can make scattering when it comes off in all regions because we are hitting different. Each part reflects at a different angle. Dull and matte, when we're having absorption, some materials are taking it all, others not apart. An object's color is determined by the part of the spectrum that it reflects and does not absorb. And whatever color comes back, that color has it. When something does reflect all colors but not red, it appears red. And when the mixture, if someone has, I don't know, blue and green, whatever, it gives violet, probably. So we're having reflection, then we're having scattering, and then we're having absorption, and then we're having refraction. When we think of the window, it passes when it's a harder medium or denser medium, and when it bends toward, after it out again, and when we're having dispersion. Dispersion, I don't know what dispersion means. Dispersion of, that means to spread. Dispersion of white light. Light comes into a prism, different wavelength, 7 of 100,000th red, violet 0.3 of 100,000th centimeter, and that makes it come out because of wavelength at different angles, and then we're having the rainbow split it out. Let's try it. I'm going to start the second camera and try to save it. Reflection, and then scattering, absorption, then we're having, what is it called? Refraction, so it's reflection and refraction. And having dispersion of light. Different interactions of light with different surfaces or materials. Now, there's, for example, a reflection. By reflection, the things come onto a flat surface and they go away in the same angle as they hit. So same angle reflection, and it appears when white. Flat surface, it appears white. Same angle. And then there is, for example, scattering. It is a rough surface, and now every point is different on the surface, and it scatters in different directions. It appears now mud or dull. And then there is absorption. And the light comes and is absorbed, the color is absorbed, and the color an object has is determined on the color which is reflected. So it can be that the colors all come in, all the colors of the rainbow. So basically light has different colors of the rainbow. It has red, blue, green, yellow, whatever. And they're coming all together as the full light. And when they enter, some objects don't return the blue part, or the green part, or the blue, or the whatever part, and just the red part comes back, and that object looks red. So the color an object has is determined on which colors are absorbed and don't come back of light, and which coming back are reflected. Now, and when there is refraction, and that is that the light basically, for example, goes through air and hits then a glass window, and then comes out of it again. But now it happens the following: the air comes in an angle, and as soon as it enters the denser glass, it will turn towards it. So light comes and turns towards the harder material, the glass, and after it leaves again, it turns again away. So it comes, while it goes through it, it turns then towards it, and then it turns away again. And then there is dispersion of white light. So the light has technically multiple different colors, like a rainbow. When a rainbow happens, the water droplets in the air make the different colors of light visible. And when you take a prism, such like a triangular, and you bring light into it, it comes out at the other hand in the colors of the rainbow, because light has different wavelengths. And red light, for example, has a wavelength of 7/100,000th of a centimeter, and blue light is just half as long as red light. The wavelength of photons, I think. And so red light has 7/100,000th of a centimeter, and blue light has 3 of 100,000th of a centimeter as wavelength. And so if it enters now the prism with light, the prism is a triangular, and it splits up because of a different wavelength, and it comes out in different colors. And that is according to how light behaves out of Matter and Energy on page 152. That is Reader's Digest Library of Modern Knowledge, book 1, 3, written by R. D. Harrison and Robin Carroll and David Owen. I'm going to stop the camera. That was the physics part. If you were here for physics, you can go directly to the next part. It might be possible that we're going to do another video to how light behaves, but maybe not. Then we're going to do something else in physics. If you stay here and participate in the body center training, that is at the arm risk. One leg up, pull the leg up, point with the toes down. Other leg up. And bring the leg to the side, point with the toes in front, and we're stretching the inner side of the leg. Other side. Then break into the middle. Have the legs standing hip width wide apart, a bit down, flex the legs, and press the legs together. Now straighten one leg slowly. Press together, flex all time. And back it again. Other leg. Straighten it, press together, and flex all time. And back again. And up, a bit wider apart. Press together, flex, and a bit more down. And straighten again one leg. Press together, flex other leg, straighten it. Down again. A bit closer together and press to the outside. Now, one leg up, right angle of the leg, flex foot, even line hips taller with the back, and press from the top against the knee. Have a little bend in the elbow. Press from the inside. Press up and to side, up to side. Press from the outside. Open slow. Close again. Other leg up, press on top. Side. Press up to side, up to side. Press on the outside. Open slowly. Close again. No free exercise on the ground. First a side leg. Just a side leg. And then if you like, you can one arm, one leg up. And on the same one, the long arm. You can one arm up, leg up, and bring elbow to knee. And over to the other side. First on the elbow. Then if you like, one leg up. Now the long arm. Arm on, leg up, and bring knee to elbow. walk a bit all over the place. And one heel onto the ground, pull the leg in, with the toes in, move the leg from left to right. Our heel onto the ground, pull the toes in and move the leg from left to right. Leg flat apart, breathing around. And breathing out. Breathing in, close the legs. And breathing out. Great pause for fast and body center training. I thank you very much, and until next time.